Hello and welcome to this video on multiplying decimals. This is the first video that you should watch if you're just starting out with this topic. A really good starting point for multiplying or indeed dividing is to know your times tables. At the very least, you really need to try and learn up to 9 times 9. But ideally, do try and learn up to 12 times 12. In this video, I'm going to show you two different methods for multiplying numbers. One that I'm going to call the diagonal method, and one called the column method. So let's start with example number 1. It says work out 56 multiplied by 3. Before we even start on this question, I strongly recommend that you do an estimate to start off with. So let's do that. 56 multiplied by 3. So I'm trying to find numbers from 56 and 3 that are going to make an estimate really easy. So let's say 56 is 60. It's nearly 60, so let's call 56 60. And I'm just going to keep the 3 as it is. So 60 multiplied by 3, how do I make this easy for myself? Well, I can think about my times tables. 6 times by 3 is 18, and then I've got the 0 here that I can pop on the end here. So my estimate is 180. So I need to be looking, when I'm looking at my final answer, I need to be looking in the region of 180. Okay, so let's do this. I'm going to start off with the diagonal method that I've started to set up over here on the left. So how do we do this? Well, first of all, you need to look at your question and look at how many digits there are in your question. So here I've got a 2-digit number that I'm multiplying by a 1-digit number. So I have done 2 boxes like so. Because I'm going to put my digits along like this, 5, 6, and I only needed to go down 1 box because I was only multiplying by a single digit. If you're multiplying by a double digit, you'd go down 2 rows, and more examples of that will be given in the next video. So what do we do now? And this is why it's called the diagonal method, or I like to call it diagonal method anyway. It is referred to as other different names, but for the purposes of this video, I'm just going to call it the diagonal method. So why is it called the diagonal method? Well, it's because we draw a diagonal line. And how do we draw this diagonal line? Well, you draw it from the top right of the box to the bottom left of the same box. Okay, so that is how it needs to look. And then I tend to take it just a little bit further like that. Lots of students make an error with this because they draw the line like this. Okay, this is incorrect. The line needs to go from the top right to the bottom left of the same box, and then just take the line a little bit further. So top right to bottom left. I'm then going to colour coordinate these boxes. So I'm going to colour that in green. I'm going to colour this in yellow, and I'm going to colour this in purple. You don't need to do this. This is just so I can explain it to you clearly by referring to some colours. So with this diagonal method, what do? We now multiply these two numbers. So we do 6 times 3, which is 18, and you put the tens part of your answer, in this case 1, in the top corner, and the units part of the answer in the bottom corner, like that. So 6 3s are 18. For this box, which I know has now been split into 2 triangles, we do 5 times 3, which gives me 15. The final part of this diagonal method is to add along the diagonals, which I've coloured in. Now, when you get bigger numbers, you'll have more of these to add up, but for this example, it's just quite straightforward because there's only 1 number here, for example. Here, I'm just going to add along the greens. As I say, there'll be more digits in bigger, if you're multiplying bigger numbers, but you add along the diagonals. So in this case, adding along the greens, which is just 8, adding along the yellows, which is 5 plus 1, which is 6, and adding along the purples, which is just 1. So 1, 6, 8 are the digits of my answer. My estimate was 180. So this looks to me absolutely fine to be my final answer. The estimate really, really becomes important, especially when you're dealing with decimals. At the moment, we've just got a whole number here, 56 multiplied by 3, but this really becomes useful when we're doing decimals. So let's have a look at the column method now. So what do we do the column method? We do 3 multiplied by 6, which is 18. You put the units part here and you carry the 10 forward. Then you do 5 times 3 in like a diagonal motion there. 5 times 3, which is 15. And then you add that 1 to give you 16. And you can see that gives me the same answer as I got over here. So I'm pretty confident that's the right answer. Okay, example number 2. Work out 6.7 multiplied by 5 now. This is where the estimate is really important. So 6.7, what can I say that basically is? It's basically 7. And I'm multiplying it by 5, so my estimate therefore is 35. So let's do the diagonal method. You're going to put 6 and 7. I'm not going to bother putting the decimal point here because I've got my estimate, so I know what region my answer's got to be in. So I'm just going to ignore that decimal point now. I'm going to put the 5 here. This box I do 7 times by 5, which is 35. This box I do 6 times 5, which is 30. And now I add along the diagonals. So add along the greens, which is 5. Add along the yellows, 3 plus 0 is just 3. And add along the purples, that's just 3. So there I have it. The digits of my answer are 3, 3, 5. But that's not my final answer because remember I did 6.7, not 67 like I did here. So I'm going to go back to my estimate and I'm going to say, well, my estimate was 35. So where would I put a decimal point to give me something in the region of 35? Well, I'd have to put the decimal point here because that gives me a number closest to 35. Okay, let's have a look at the column method. I'm going to do 7 times by 5 to begin with, which is 35. Put the units part here, carry the tens part forward. Then I do 6 times 5, which is 30, plus the 3, which gives me 33. And then again, my answer, if I thought about the decimal point, it would go there. So my final answer is 33.5. Example 3. 2.6 multiplied by 8, let's do an estimate. 2.6 is basically 3, and 3 times 8 is 24, so my estimate is 24. Let's put the digits along here, 2, 6, and 8. Here I do 6 times 8, 6 8s are 48. Here I do 2 8s, which are 16. Add on the greens, I get just 8. Add on the yellows, I now get 10. What do I do if I get 10? I don't write it like this. I don't write 10 like that. I just put the 0 here of the 10, the 0 of the 10 there, and I carry a 1 forward. I'm just going to put it in a different colour. Now I need to add along the purples, but you've got to include that one that we just carried there. So 1 plus 1 is 2. So 208 are the digits of my answer. Where do I think my decimal point is going to go? Well, my estimate was 24. What number can I get close to 24 there? 20.8, I reckon. Let's do the column method now. 6 8s are 48. You put the units part here and you put the tens part of your answer here. 2 8s are 16 plus 4 is 20. So you put your whole final part of your answer here, 20. 208 are the digits, and then thinking about the decimal point, so 2.6 multiplied by 8 gives me a final answer of 20.8. Example number 4, 2.9 multiplied by 4. Let's do an estimate. Well, 2.9 is basically 3. 3 multiplied by 4 is 12. So I'm looking for an answer in the region of 12. Let's put the digits along here. 2 and 9 and 4. 9 fours are 36. 2 times 4 is 8. How do we put 8? Well, if you think about it, 8 is just 8 units and no tens, isn't it? So that's how we write it. 0 and then 8. Adding on the greens, I just get 6. Adding on the yellows, I get 11. Remember, we don't write it like this. We don't write 11 like that. We write the units part of the 11 here, which is just 1, and then the tens part of the 11 here to make it 11. And then I'm adding on the purples, which is just 0 plus that 1 there, which gives me 1. So the digits of my answer are 116. My estimate was 12, so I reckon that my decimal point goes here, 11.6. Let's do the column method. 9 fours are 36. You put the units part there, the tens part there. 2 fours are 8. Plus 3, 8, 9, 10, 11. So you put the full 11 here. And then in a similar way to what I did over here, think about your estimate, think about where your decimal point goes. The final answer is 11.6. Example 5. Work out 37 multiplied by 0.6. Okay, this is a different kind of one to what we're used to. We're now multiplying by 0.6, which is less than 1. It is under the value of 1. So my estimate is just going to be 37 multiplied by, well, 0.6. I don't want to make it 0.5 or anything like that. That's just going to make it difficult. I'm actually just going to round to 1. 0.6 is close enough to 1. So my estimate's actually 37. But if you think about it, 0.6 is less than 1. So your answer's going to be less than 37 because you're multiplying by a number that is below 1. So let's watch out for that at the end. 37 multiplied by 0.6. Now I'm not done 2 rows here because I'm not really worried about that 0 because I've already got an estimate. So I'm actually just going to put 6 here. The 6 from here. 7 sixes are 42. 3 sixes are 18. Add along the diagonals, add along the greens, I just get 2. Add along the yellows, I get 12. Remember, put the units part there, the tens part there. Add along the purples, 1 plus 1 is 2. So 222 are the digits of my answer. But my estimate was 37. But remember, multiplying by 1 gave me 37, but I'm multiplying by less than 1. So what's a number that is less than 37? Well, the only number I can see that's less than 37 there, by putting the decimal point in, is there, 22.2. Does it seem reasonable? Yeah, because I'm multiplying by a number less than 1. Okay, let's do the column method. 7 sixes are 42, you put the units part there, the tens part there. 3 times 6 is 18, plus 4 is 22, so you put the full part here of your answer, 22. And again, you think about your final answer and where the decimal point goes. So the answer to that one is 22.2. Example 6, work out 64.1 multiplied by 8. So again, start off with an estimate, 64.1. I'm just going to say that's 60. And I'm multiplying it by 8. Well, 6 eighths are 48. And then I've got the 0 here, which I put on the end. So my estimate is 480. Okay. So now you can see I've got 3 digits here. Okay, so I've just got 3 boxes now that I've drawn. So 6, 4, 1, But I'm still only multiplying by 1 digit, so I only need to go 1 box down. But the same rules apply in terms of drawing your diagonals. So top right to bottom left, top right to bottom left, top right to bottom left. And then I'm just going to colour them in, just to make it nice and straightforward. So yellows. Now we've got some more purples to add up, and let's say that one's blue. Okay, so what do we do here? We do 1 times 8. So remember, 1 times 8 is just 8, so we've got 8 units, but no tens. This box we're doing 4 eighths. 4 eighths are 32, so 32 goes there. And this box here is 6 times 8. 6 eighths are 48. Add along the greens, which is 8. Add along the yellows. 0 plus 2 is 2. 8 plus 3 is 11. So you put the units part of the 11 there and the tens part of the 11 there. So that makes 11. Add along the blues. 4 plus that 1 gives me 5. So the digits of your answer are 5, 1, 2, 8. But my estimate was 480. 480, so it's not going to be 5,128, it's going to be 512.8. It's just worth saying at this point, I've drawn it as 3 by 1, but you get exactly the same answer if you do your boxes the other way round, and you could put your 8 here and your 6, 4, 1 down the side. That's absolutely fine. Let's do the column method. 1 times 8 is 8. 4 times 8 is 32. You put your 2 there and you carry your 3. And then you do 6 times 8. 6 times 8 is 48. Plus 3 is 51. 5128, and then think about your decimal point, and you get the answer there to be 512.8. Example 7. Work out 91.7 multiplied by 6. Let's do an estimate. 91.7, I'm just going to say that's 90. 90 multiplied by 6, well, 9 6s are 54. So 90 multiplied by 6 is 540. So let's put this along the top here. 917 multiplied by 6. 7 6s is 42. 1 6 is 6. That's a 0. Ooh. Make that a bit clearer. So no tens, but 6 units. 9 6s are 54. Add along your diagonals, add along the greens, it's 2. Add along the yellows makes 10. Add along the purples, 0 plus 4 plus 1, don't forget that 1 there, is 5. And add along the blues is just 5. So the digits of your answer are 5, 5, 0, 2. My estimate was 540, so I reckon my decimal point's going to go there. 550.2. Let's do the column method. 7 6s are 42, put the units there, carry the 4. Then you do 1 times 6. 1 times 6 is 6, plus the 4 is 10. 9 times 6 is 54, plus 1 is 55. So again, you can see the final answer there is 550.2. Example 8, work out 7.58 times by 0.7. 7.58, let's call that 8, and then you're multiplying by 0.7. Now 0.7 is below 1, so we're going to get an answer that is lower than 7.58. So I'm just going to say that that's 8 times 1. which is 8, but we know it's going to be much less than that. So let's do this. 7, 5, 8. And I'm not going to put the 0, I'm just going to put the 7. Because I've got my estimate. My estimate is 8, so I know I'm looking for something in the region of 8. 8 times 7 is 56. 5 times 7 is 35. 7 times 7 is 49. Adding along the greens is 6. Adding along the yellows, 10. Adding on the purples, 9 plus 3 is 12, plus another 1 is 13. Adding on the blues, 4 plus that 1 there is 5. So digits of my answer are 5, 3, 0, 6. Be really careful that you don't include these little carried ones in your final digits of your answer. Okay, so the final digits of your answer are 5, 3, 0, 6. Look at the estimate. The estimate was 8, but we know if we're doing 7.58 multiplied by a number less than 1, it's going to be lower than 7.58 even. Yes, this is my estimate, but I've got to think back to the question. It's going to be less than 7.58, so I reckon the final answer is 5.306. Let's do the column method. 7 eighths are 56 units there. Carry the 10s. 7 times 5 is 35, plus 5 is 40. And 7 times 7 is 49, plus 4 is 53. 5.306, but 7.58 times 0.7 is 5.306. Example 9, work out 50.8 times by 0.7. So again, you're multiplying by a number less than 1, but let's just, for argument's sake, let's just say that's 50 multiplied by 1. Oops, 50 multiplied by 1. So I know that I'm looking for something in the region of 50, but actually it's going to be less than even this number because we're multiplying by a number less than 1. I'm not going to put 0.7, I'm just going to put the 7 part here. 5, 0, 8, 7 eighths and 56. 0 times 7, don't trip up here. Anything times 0 is 0. 0 times 7 is 0. So zeros go in both these parts here. 5 times 7 is 35. Adding on the greens, I just get 6. Adding on the yellows, I get 5. Adding on the purples, I get 5. Adding on the blues, I just get 3. So the digits of my answer are 3, 5, 5, 6. My estimate was 50, but actually I know it's going to be lower than that. It's going to be less even than 50.8, so it's not going to be 3,556. It's not going to be 355.6. It's going to be 35.56. Let's do the column method. 7 eighths are 56. 0 times 7 is 0, plus 5 is 5. And 5 times 7 is 35. So you put the 35 here. Final answer to that question is 35.56. Okay, here are a couple of questions for you to have a go at yourself. So pause the video now, have a go at these, make sure you show your workings. And when you think you have finished, you can resume the video to see the answers. So I will show you the answers now. Very well done for having a go at those.